9x squared y to the third minus 27 x to the sixth times 1 over y, since we're still left with a y there, all over y to the sixth. Okay. Now if we want to simplify this a little bit more, we can actually multiply this by y over y. Oh, move that over a little bit more. Okay, so if we multiply both of those terms by y, we have 9x squared y to the fourth minus 27x to the sixth. Actually got rid of that y once we distribute it. All over y to the seventh. All right, and that would be your final answer. All right, any questions on that one? All right, leave that up for a few. All right. Oops. Okay, so now we're going to cover the derivative of natural exponential functions. Okay, so we have the derivative of x, or derivative with respect to x, of e to the x is e to the x, and the derivative of e to the, let's say, some function other than just x, would equal e to the g of x times g prime of x. Okay, so we're just going to prove the first one. The second one's pretty similar. Derivative of e to the x with respect to x, it's going to equal the limit of f of x plus h, which is ex plus h, minus f of x, so minus e to the x, all over h, as h approaches 0. Okay, which equals the limit of e to the x times e to the h minus e to the x all over h as h approaches 0. So if we factor out an e to the x from both of those, you have the limit as h approaches 0. We can just bring that e to the x out front, times e to the h minus 1, clean that up, all over h. Okay, which gives us the limit of e to the x as h approaches 0 times the limit of e to the h minus 1 over h as h approaches 0. Okay, so if we actually found the limit from the left and to the right approaching that point, or approaching 0, you actually find that the limit is equal to 1. So here, if we use direct substitution, the limit of e to the x, if you plug in h, there is no h to equal 0, So that just equals e to the x, which is e to the x. And actually, you can solve this also using L'Hopital's rule, but we haven't gotten there yet, so that's why that couldn't quite do it that way. All right.
So if derivative of e to the x is e to the x?
Yep. Now, one of the easier ones to remember. Okay, so let's say, for example, I want to find the derivative of f of x equals e to the 3x. Okay, so this one we're going to use the derivative of e to the g of x, which is equal to e to the g of x times g prime of x. Okay. That means if we wanted to find the derivative of e to the 3x, that would just be e to the 3x times the derivative of 3x. Okay, which would equal e to the 3x times 3, or just 3e to the 3x. And that's your final answer. All right, so let's do one more example. So if we want to find the derivative of, let's say, f of x equals e to the 5x to the third over 2x. Okay, so here we're just going to have to use the quotient rule. It would help if I can capitalize that. Okay, so your denominator, well, let's say f prime of x equals your denominator times your derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. Okay, so that's going to equal 2x times the derivative of e to the 5x cubed, which is e to the 5x cubed times the derivative of 5x cubed. Minus e to the 5x to the third times the derivative of 2x, which is just 2, all over 4x squared. Okay, so this is going to give us 2x times e to the 5x to the third, and the derivative of 5x to the third, if we bring down our 3, will give us 15x squared, minus 2e to the 5x to the third, all over 4x squared. Okay. So, if we wanted to simplify, we could actually factor out a 2e to the 5x to the third. Okay, which will leave us with 15x to the third minus 1 all over 4x squared. And then if we simplify the 2 and the 4, we just end up with e5x to the third times 15x to the third minus 1 all over 2x squared as our final simplified answer. All right. Any questions on that one? All right. Leave that up for a few more seconds. All right. Okay, so now we're going to find the derivative of the natural log function. Okay, so let's say if x is greater than 0 and y equals some natural log of x, then our derivative of natural log of x is equal to 1 over x. Okay. And if you also had, instead of an x, if you had a function of x in there, let's say if some g of x is greater than 0 and y equals some natural log of g of x. Clean that up a little. Then the derivative of the natural log of g of x is equal to 1 over g of x times g prime of x. Or I usually just call it, forgot to close that up, g prime of x over g of x. Which, if you look at the natural log of x, still, if you have g of x is equal to x, and g prime of x is just 1, so it applies to both. All right. So we'll give a quick proof of that one. Okay, so we know that y equals natural log of x. We apply e to both sides. E to the y equals e to the natural log of x. Okay, we know that e and natural log kind of cancel each other out. We have e to the y equals x. Okay, so what it means if we apply the derivative with respect to x of e to the y, using the chain rule, that's going to give us, don't need that again, e to the y times dy dx. Okay. Okay, so we also know that since, well, where'd it go? I forgot to rewrite it. E to the natural log of x times dy dx. We know the derivative of natural log of x is 1 over